Hi guys, 15.5 angle relationships in circles, geometry. I don't know why I keep on saying geometry. It's, who else talks about angle relationships in circles? All right, essential question. What are the relationships between angles formed by lines that intersect a circle? Okay, so take a deep breath. The measure of an angle whose vertex is on the circle is half the measure of its intercepted arc, and you'll see that in my examples. The measure of an angle whose vertex is inside the circle is half the sum of its two intercepted arcs. The measure of an angle whose vertex is outside the circle is half of the difference of its two intercepted arcs. So one's addition and then divide by 2. The other one's addition, divide by 2. But the last one, if your angle's outside, it's the two arcs subtracted and then divide by 2. And we're going to see some examples. All right, so intersecting chords angle measure theorem basically says if two secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. So chords AD and BC intersect at point E, and then now we come across the formula idea. So basically, angle 1, okay, this angle right here, equals half of AB plus CD. Okay, so it's going to be this whole guy, this arc, plus this arc, and then divide by 2. Why do we divide by 2? Because how many arcs are there? Remember averages, right? You take the total number, add them together, and then divide by how many there are. Well, in this situation, there's just 2 arcs, so then just divide by 2. So, again, you'll have to divide by 2 or multiply by 0.5 or 1/2, okay? I say divide because you don't need to worry about a numerator with 1. So let's see some examples. So in example 1, we're going to find angle MPK. So MPK is that guy right there. All right, so let's talk about the two arcs that we do have. So we have MK, that was given to us. Oh, and you know what? I just realized, silly Mr. Webb, you labeled the wrong one. MPK is this guy, okay? There we go. So MPK equals half of what two arcs do we have? We have, let's see, we have MK, that's given to us, that's 61 degrees, and NL, or LN, that's given to us. So we'll use those two angles. So again, we'll use the arc of KM plus the arc of LN. Once we do that, we're going to have this equaling 1/2 of 61 degrees plus 111 degrees. So you add those up together. And again, don't forget the 1/2. I'm just showing you all the work. In reality, if you identify which one to use, you just add these up together in your calculator, divide by 2, and you get your answer super fast. Okay, and that's where you kind of want to be for the test. So again, 61 plus 111 is 172. Half of that should be 86. 86 what? 86 degrees. Okay. So again, add up your two arcs and then divide by 2. So this one right here, find the arc Okay, so we already have our interior angle right here at 58 degrees. Now you have to find this guy right here, PR. Okay, so use this setup, and you're using the same formula. Just plug in your variables. Your variables are different now. So, for example, you have NPR, or you have one of your interior angles, which is 58 degrees. So you have 58 degrees equaling half of your two arcs. Well, you don't know one of your arcs, right? You don't know what PR is. But you do know what your other arc is. That's a plus, by the way. Plus 82 degrees. So I'll tell you what, solve that. Okay, I went ahead and set it up for you. You let me know what you get here. So that's your turn. Okay, do that one. I set it up. All right, the tangent-secant interior angle measure theorem. Okay, so if a tangent and a secant or a chord, and all those different variations may happen, intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of the intercepted arc. So basically, all you need to know is that angle ABC, okay, is going to be half of whatever your arc is, which is going to be AB. Okay, so just remember that relationship. Let's see some examples. So example 3, find the arc of PN. If you notice, basically for this, they give you the angle P, right? That's 61 degrees. So they did give us something to work with here. Now remember, the angle P, okay, that was like our ABC type deal. All right, so there's our inside guy. And he's going to equal half of what we're looking for, which is the arc of PN, which is going all the way across here. So let's see. I don't think that works. I think they're talking about this guy right here. There you go. All right, so let's go ahead and find our arc. So we set up our algebra. Remember, angle P was given to us, and that equals half of our arc that we're looking for. So angle P was 61 degrees. Fabulous. Now, how did we get rid of a multiplying 1/2? Or even better, how do you get rid of a dividing 2? Multiply both sides by 2. So your arc, okay, I should probably start doing these curvies. Okay, your arc is going to be, what's 2 times 61? 122 degrees. So that's how you can find the arc there. So now your example that you're doing, just know that your angle okay, is going to equal half of what? MNP. MNP equals half of what? So again, you're looking for this angle here. All right. They do give you a certain amount to go off of with your arc, which I believe is 230. In fact, I'll just go ahead and call it, because I think this 238, and I think the book made an error, and I think that's what was messing me up, was in the print, the fine print. Okay, this 238, it goes for all this arc, from here to all the way to here. Okay, I don't know why the book probably should have mentioned that in detail. They kind of winged it. All right, so remember your interior angle there, all right, in your vertex, is going to equal half of the major arc NQP, which I just kind of told you is going to be 238 degrees. So go ahead and set that up, plug it in, and go ahead and find me what your angle of your vertex is of MNP. All right, so again, this is your turn. All right, the tangent-secant exterior angle measure theorem. Now there's three types of situations that it can occur with these, and that's why they're doing what they're doing. So if a tangent is secant, or two tangents, or two secants intersect the exterior of a circle, then the measure of the angle formed is half the difference of the measure of its intercepted arcs. So the first one is that we have a secant and a tangent. Just know that your interior or your angle up there, it's exterior angle, I'm sorry, your exterior angle equals half of your two arcs, okay, so the big huge arc minus the smaller arc BD, okay, and that's what the exterior, if you have a tangent and a secant in this situation, okay. So just remember, big arc minus small arc times 1/2 equals that exterior angle. All right, let's look at the next one. So your exterior angle, angle 2, equals half of this big, huge major arc, okay, minus your smaller arc. You're like, Mr. Webb, isn't that like the same thing with the secant and the tangent? Well, is it? Is it? No, seriously, is it? Like, I'm asking you, okay? So, are they the same? Even though one's, see, like, what I'm talking about right here, guys, is you have a secant and a tangent, okay? And then all of a sudden you have a tangent and a tangent. Okay, so again, are they the same? Like the setup, same formula? And why? What does it have to do with those arcs? How many are there? So again, just come see me once you're done with the notes and just tell me like, yeah, they're the same, or no, they're not the same because of blah, blah, blah with arcs or something like that. Okay, so just talk to me about that. It's a good conversation piece to make sure you understand. All right, so let's go with this one. We have two secants. So your angle 3 equals half of, oh, look at that, your big arc minus your smaller arc. Wasn't that the same thing as the other ones? Okay. So now you have two secants cutting through. But it didn't really matter, did it? With the setup for the formulas. So again, reflect with your buddy, reflect with me, and just notice how basically you're going through the same process with just all these different scenarios. Okay, so let's look at some examples. So we're going to go ahead and find the value of x. We have two secant lines cutting through here. So we're going to go ahead and solve for this. remember this guy, okay, should equal the half of the big guy minus, and let me use a different color because I think I used yellow for the smaller one, right? Equals, was it the green that was, yeah, it was the green that was the smaller one. So there we go. Okay, so there's the setup. We have 25 degrees equaling half, okay, this is the setup of the bigger guy, 83 degrees, minus the smaller guy, which is just left as x. So notice how I'm using the same setup, it's just the numbers, you know, they just come and go. Alright, so let's go ahead and get rid of that dividing 2. Got to get rid of a dividing 2. Multiply both sides by a 2. You have 50 equals 82 minus x. Let's go ahead and move the x over and get rid of this 50. So I'll minus the 50 here. And to get rid of a minus x by adding. So I'll have x equals 32. 32 what? 32 degrees. Oh, Mr. Webb made a little tiny mistake. It's not 82, Mr. Webb. It's 83. Okay. He's losing his mind, I think. Who knows? All right. There we go. 33 degrees. So we use that formula to figure it out. Now this one is a little bit more just like my notes. So that's definitely on you. Okay. Remember the setup? I'll give you a hint. Blue guy, okay, equals half of the big guy minus, okay, the small guy. So that one's on you. All right, quiz a buddy. So I want to do something a little different today. You're going to choose some values for the cutout, okay, for the arcs, anywhere from between 10 to 180 degrees, and see if your buddy can solve it, okay? Just remember that JN's got to be bigger, okay, than KN. Okay, so you're actually going to find some numbers. All right, so degrees here, some degrees here, and then your buddy has to solve for your exterior angle. Okay, so create a problem, give it to the person right next to you, see if they can solve it. If they can't, go through their notes with them, discuss the process they need, and then solve it, and then come see me. Okay, work together, see if you guys can figure it out, see if your buddy can figure it out first on their own. All right, if not, then work with them and look over the notes and talk about it. Okay, all right, and here's the homework. Page 836 through 838, numbers 3 through 13, and 15. 15 is a multi-layered cake, should be fun. All right, good luck. Let me know if you have any questions.